Hi everyone, welcome to Eve Math Tutoring. Today's lesson is on rational versus irrational numbers. So the question is, how do you determine if a number is rational or irrational? So say you're dealing with, let's look at rational first. So rational numbers, first of all, if you have a whole number, that is rational right off the bat, okay? Now, if you have any other number, what you're going to do is you want to convert the number into decimal form. Okay, and once you do that, if the decimal stops, then we have a rational number. Or if the decimal continues, however, it has a pattern, so and has a pattern. Here, I'll just write decimal continues and has a pattern, then it is rational. So it's also rational, okay? So let's do a couple of examples. So say you have the number 7. That right there is a rational number. Because it's a whole number, it is rational. If you have the fraction 1/2, when a number is in fraction form, it's very hard to determine if it's rational or irrational. So what you're going to do is you're going to convert it into a decimal, and then you can determine if it's rational or irrational. Now in this case, we do 1 divided by 2 on the calculator, and we get 0.5. Because this decimal stops, this right here is a rational number. Okay? Now say we had -3/5. Again, we convert this into a decimal, so we get -0.6, and because it stops, it is a rational number. Okay? I'll give you another example. You have -98/99. So in this case, again, you convert it into a decimal form. And when you do that, you're going to get 0.9898. And it just keeps on going. You keep getting this pattern. So because these two numbers keep reoccurring and you have like a pattern that you see over and over, this is actually a rational number. Okay, and actually in mathematics, when we have a repeating pattern, what we do is we usually just write the two numbers that repeat with a line on top, and that represents the decimal, and it this format here in mathematics means that this part here just keeps on reoccurring. That's the part that's the pattern in this decimal. So those two numbers just keep consistently reoccurring and just keep going on and on, so never ending. Okay, so this is a rational number. Now I'm going to show you a more interesting example. So now say you get something like the following. So something that's not very obvious right off the bat. So 57 divided by 23. Now in this case, some numbers, like in this case, when you plug it into the calculator, you're going to see, just show you what you get here. So you get 826695652173913043, and then 43478260, etc. And it keeps on going. Okay, now when you originally plug this into the calculator, you're going to probably see the first 12 digits, so you might just see up to this number. Now at that point, it looks like it's irrational. Now you have to be very careful, because I would recommend in this case, if you get a number like this, I would recommend using a computer program so that you get the ultimate number of decimals. And the reason for that is, if you look carefully at this number, you have these 22 digits. And then after those 22 digits, the same digits start to reappear. So now you see, again, 4, 7, 8, 2, 6, etc. Okay, that starts to reappear. So it's 22 digits. That's the pattern, and those 22 digits keep reoccurring. Okay, and the only way to see that would be probably using something like a computer program, and this still is considered a rational number because it's 22 digits. However, those 22 digits will keep reoccurring. Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yep, 22 digits. And after that, you see the same 22 digits just start to reoccur. And to get this, so this is rational. But however, like I said, a calculator may not give you that. So I know the program I used was called Wolfram Alpha. So it's Alpha. It's a program on the internet, and you can just go into there. It's Wolfram Alpha. It's a computer program. So what you do is you actually plug in the number, and it will give you the full amount of decimals. So you can use a program like that one, for example. That's the one I know of, Wolfram Alpha, ALPHA. So when you get something tricky like this, you can use a program like that, and that will give you the full amount of decimals. And at that point, you know now that you're dealing with rational. So that's an easy one to mix up, okay? You want to see all the decimals, and then you can decide if it's rational or irrational. Okay, so let's do another couple of examples here. Now say for the number root 2, get 1.414213, etc. And it keeps on going. Actually, it has no pattern, and you'll see that if you get the full amount of decimals. So this is actually an irrational number. Okay, so when I say no pattern, I mean getting the number 41 in here somewhere, however, getting all different numbers, like not the same numbers that you see here, is not considered a pattern. It has to be the consistent same numbers that reoccur over and over. So the same 2 digits that reoccur, or in this case, the same 22 digits that reoccur in the exact same order. Okay, so having, you know, the number 5 again here, however, you have a 4 in front of it, and it doesn't follow your pattern that you see, that's not considered like a pattern. So that's irrational. Okay, so even if you see the same numbers, they have to be in the exact same order, and it has to be a reoccurring, you know, it could be 8 digits that just reoccur in a consistent pattern. So that would be rational. But in this case, we see a whole bunch of numbers and we don't see a consistent reoccurring pattern. So that is irrational. Okay. So if I saw the number 2 over here, but in front of it was a 3, so there was another number 6 or something, then that's not, you know, this 2 reappearing, because you want to see the same set of numbers reappear. Okay, so let's try another example. So something like the third root of 5. Now in this case, you want to plug this into your calculator. So every scientific calculator is different. So you're going to do the third root of 5. And sometimes you can even express this as a exponent. So there's actually a 1 here that's not written. And this is the 3. That's the, you know, if there's nothing written here, it's always a 2. But if there is something other than 2 written here, then I'm just going to make that a little bit smaller, because it's the cube root of 5 that I'm looking at. So it's actually like really small. Okay, so if there's nothing written here, there's actually a 2 when you have roots, and there's always, you know, the exponent here. If there's nothing written, it's a 1. Okay, now if there's a number written, then that means it's bigger than 2, your root. So in this case, it's a 3. So what you can do is you can actually express this in exponent format with the number 5. And when you do that, you can plug that into your calculator. So either this way or that way, either way. And when you do, you're going to get the number 70997594, etc. And it keeps on going, and it has no pattern. Okay, keeps going, no pattern. Therefore, this number is irrational. This is an irrational number. Okay, let's try another example. Let's try root 7. Here's a 1, Here's a 2. They're not actually shown, so that means that, but those are the numbers that are there when they're not written. You plug in root 7 into the calculator, and you're going to get 2.645751311. And it keeps on going, and it has no pattern. Therefore, it is irrational. Okay, that's also an irrational number. See, in this case, you see, the 1's reoccurring, but you're going to see there's no consistent pattern. So just a whole bunch of numbers, and there's no consistent set of numbers that keep on occurring. Okay. The number pi, if you plug pi into the calculator, 3.1416, etc., it keeps on going. It has no pattern. So it is irrational. E. If you plug e into the calculator, e to the power of 1, okay, you're going to get 2.7182, etc. Again, no pattern. Therefore, irrational. Okay, so that's how you tell the difference between rational and irrational. So rational numbers will either stop or they will continue. It will be a whole number. It will either, in decimal form, it will stop, or if it continues, it will have a consistent pattern with consistent numbers that are reoccurring. So maybe 7 numbers that just keep repeating over and over, or like before, the 22 digits that keep repeating over and over, or 2 digits that just keep repeating in the same order over and over. Okay. In irrational, you'll see that you're gonna get a decimal when you plug the number in. You're gonna get a decimal that's gonna keep on going, and it's gonna have absolutely no pattern. And in that case, you've got an irrational number. But again, like I said, it is hard to tell unless you have maybe a computer program that you can plug in, like access to some sort of a computer program like Wolfram Alpha, where you can just plug in the number and from there get the biggest amount of decimals. And when you do that, you will see for sure. You can tell then if you're dealing with a rational or an irrational number. Okay, so just the lesson on rational versus irrational numbers. If you have any questions, feel free to email me at evemathtutoring@outlook.com. If you want any, if there are some examples that you're not sure about, go ahead and email me or post the questions on the channel, and we can try those out and we can see if they're irrational or rational. Okay, so I hope you enjoyed the video.